Jupyter is an interactive computing environment that allows you to create and share documents containing live code, equations, visualizations, and narrative text. Jupyter Notebooks support various programming languages, including Python. To install Python on your system, you can follow these general steps. Download Python. Visit the official Python website at https://www.python.org/ and download the Python installer appropriate for your operating system, Windows, Mac OS, or Linux. Run the installer. Once the installer is downloaded, run it and follow the installation instructions. Make sure to check the option that adds Python to your system's path during the installation process. This ensures that you can run Python from any command prompt or terminal window. Verify installation. After the installation is complete, you can verify that Python is installed correctly by opening a command prompt, Windows, or Terminal, Mac OS/Linux, and typing Python version or Python 3 version. This command will display the installed Python version. Install Jupyter. After Python is installed, you can install Jupyter using Python's package manager, pip. Open a command prompt or terminal and type pip install Jupyter. This command will download and install Jupyter and its dependencies. Run Jupyter Notebook. Once Jupyter is installed, you can launch the Jupyter Notebook interface by typing the following command in your terminal or command prompt. Jupyter Notebook. This command will start a local server and open your default web browser to the Jupyter Notebook dashboard, where you can create, open, and manage your Jupyter Notebooks. That's it. You've successfully installed Python and Jupyter on your system. You can now create Python notebooks and start coding interactively. Jupyter does offer an interactive environment primarily through Jupyter Notebooks and Jupyter Lab, which provide features similar to an IDE for Python and other programming languages. Here's a brief overview of both. Jupyter Notebooks. Jupyter Notebooks provide an interactive computational environment for creating documents with live code, visualizations, and narrative text. Notebooks run in a web browser and allow you to write and execute Python code in a cell-based format. You can also include markdown cells for documentation and explanation. Notebooks support code completion, syntax highlighting, and integration with various data visualization libraries. To use Jupyter Notebooks, you typically install the Jupyter software, as described in the previous answer, and launch the notebook server with Jupyter Notebook. Jupyter Lab. Jupyter Lab is the next-generation web-based user interface for Project Jupyter. It provides a more flexible and powerful user interface for Jupyter Notebooks, along with support for text editors, terminals, data file viewers, and custom components. Jupyter Lab offers features similar to traditional IDEs, such as tabbed interface, customizable layout, code consoles, file browser, and integrated text editors. You can install Jupyter Lab using pip install Jupyter Lab, and launch it with Jupyter Lab command. While Jupyter Notebooks and Jupyter Lab offer a rich environment for interactive Python development and data analysis, some users prefer more feature-rich IDEs such as PyCharm, VS Code with Python extension, or Spider for their Python development needs. These IDEs often provide advanced features like debugging tools, version control integration, project management, and more extensive customization options. Jupyter does offer an interactive environment primarily through Jupyter Notebooks and Jupyter Lab, which provide features similar to an IDE for Python and other programming languages. Here's a brief overview of both. Jupyter Notebooks. Python, a high-level programming language, was conceptualized and developed by Guido van Rossum, a Dutch programmer, in the late 1980s. Its creation was influenced by his desire to create a language that was easy to read and understand. The history of Python can be outlined as follows. Early development, late 1980s, early 1990s. Guido van Rossum began working on Python in December 1989 at the National Research Institute for Mathematics and Computer Science, CWI, in the Netherlands. Python's design was inspired by several programming languages, including ABC, Modular 3, C, C++, and others. The first version of Python, Python 0.9.0, was released in February 1991. It included features such as exception handling, functions, and modules. Python 1.0, January 1994. Python 1.0 was released with features like lambda, map, filter, and reduce functions. The release of Python 1.0 marked a significant milestone in Python's development as a stable and usable programming language. Python 2.x series, 2000 to 2008. Python 2.0, released in 2000, introduced important features such as list comprehensions and garbage collection. The Python 2.x series saw several updates and improvements, including the addition of features like decorators, generators, and iterators. Python 3.0, December 2008. Python 3.0, also known as Python 3000 or PY3K, was a major revision of the language that aimed to clean up and modernize Python syntax and semantics. Python 3.0 introduced backward-incompatible changes to address inconsistencies and improve language design. The transition from Python 2.x to Python 3.x was gradual due to compatibility concerns, with both versions being actively maintained for several years. Python 3.x series, 2008, present. Python 3.x series continues to be actively developed and maintained, with regular releases introducing new features, improvements, and optimizations. Python 3.x is the recommended version for new projects and development, as Python 2.x reached its end-of-life status in January 2020. Community and adoption. Python's success can be attributed to its simplicity, readability, versatility, and vibrant community. Python is widely used in various domains, including web development, data science, machine learning, scientific computing, automation, scripting, and education. The Python Software Foundation, PSF, established in 2001, oversees Python's development, community, and governance. Python's popularity continues to grow, with millions of developers worldwide using it for diverse applications. Its simplicity, readability, extensive standard library, and ecosystem of third-party libraries and frameworks make it a preferred choice for many programmers and organizations. Software quality. Python code is designed to be readable, and hence reusable and maintainable, much more so than traditional scripting languages. The uniformity of Python code makes it easy to understand, even if you did not write it. In addition, Python has deep support for more advanced software reuse mechanisms, such as object-oriented, and function programming. Developer productivity. Python boosts developer productivity many times beyond compiled or statically typed languages such as C, C++, and Java. Python code is typically 1/3 to less to debug, and less to maintain after the fact. Python programs also run immediately, without the lengthy compile and link steps required by some other tools, further boosting programmer speed. Program portability. Most Python programs run unchanged on all major computer platforms. Porting Python code between Linux and Windows, for example, is usually just a matter of copying a script's code between machines. Support libraries. Python comes with a large collection of pre-built and portable functionality, known as the standard library. This library supports an array of application-level programming tasks, from text pattern matching to network scripting. In addition, Python can be extended with both homegrown libraries and a vast collection of third-party application support software. Python's third-party domain offers tools for website construction, numeric programming, serial port access, game development, and much more. See ahead for a sampling. Component integration. Python scripts can easily communicate with other parts of an application, using a variety of integration mechanisms. Such integrations allow Python to be used as a product customization and extension tool. Today, Python code can invoke C and C++ libraries, can be called from C and C++ programs, can integrate with Java and .NET components, can communicate over frameworks such as COM and Silverlight, can interface with devices over serial ports, and can interact over networks with interfaces like SOAP, XMLRPC, and Corba. It is not a standalone tool. Enjoyment. Because of Python's ease of use and built-in toolset, it can make the act of programming more pleasure than chore. Although this may be an intangible benefit, its effect on productivity is an important asset. Of these factors, the first two, quality and productivity are probably the most compelling benefits to most Python users, and merit a fuller description. It's object-oriented. Python is an object-oriented language, from the ground up. Its class model supports advanced notions such as polymorphism, operator overloading, and multiple inheritance, yet in the context of Python's dynamic typing, object-oriented programming, OOP, is remarkably easy to apply. Python's OOP nature makes it ideal as a scripting tool for object-oriented systems languages such as C++ and Java. For example, Python programs can subclass specialized classes implemented in C++ or Java. It's free. Python is freeware, something which has lately come to be called open source software. As with TCL and Perl, you can get the entire system for free over the internet. There are no restrictions on copying it, embedding it in your systems, or shipping it with your products. In fact, you can even sell Python, if you're so inclined. But don't get the wrong idea, free doesn't mean unsupported. On the contrary, the Python online community responds to user queries with a speed that most commercial software vendors would do well to notice. It's portable. Python is written in portable ANSI, and compiles and runs on virtually every major platform in use today. For example, it runs on Unix systems, Linux, MS-DOS, MS Windows, 95, 98, NT, Macintosh, Amiga, BOS, OS/2, VMS, QNX, and more. Further, Python programs are automatically compiled to portable bytecode, which runs the same on any platform with a compatible version of Python installed. More on this in the section It's easy to use. What that means is that Python programs that use the core language run the same on Unix, MS Windows, and any other system with a Python interpreter. It's powerful. From a features perspective, Python is something of a hybrid. Its tool set places it between traditional scripting languages, such as TCL, Scheme, and Perl, and systems languages, such as C, C++, and Java. Python provides all the simplicity and ease of use of a scripting language, along with more advanced programming tools typically found in systems development languages. Automatic memory management. Python automatically allocates and reclaims, garbage collects, objects when no longer used, and most grow and shrink on demand. Python, not you, keeps track of low-level memory details. Programming in the large support. Finally, for building larger systems, Python includes tools such as modules, classes, and exceptions. They allow you to organize systems into components, do OOP, and handle events gracefully. It's mixable. Python programs can be easily glued to components written in other languages. In technical terms, by employing the Python/C integration APIs, Python programs can be both extended by, called to, components written in C or C++, and embedded in, called by, C or C++ programs. That means you can add functionality to the Python system as needed and use Python programs within other environments or systems. It's easy to use. For many, Python's combination of rapid turnaround and language simplicity make programming more fun than work. To run a Python program, you simply type it and run it. There are no intermediate compile and link steps, as when using languages such as C or C++. As with other interpreted languages, Python executes programs immediately, which makes for both an interactive programming experience and rapid turnaround after program changes. Strictly speaking, Python programs are compiled, translated, to an intermediate form called bytecode, which is then run by the interpreter. It's easy to learn. This brings us to the topic of this book. Compared to other programming languages, the core Python language is amazingly easy to learn. In fact, you can expect to be coding significant Python programs in a matter of days, and perhaps in just hours, if you're already an experienced programmer. Internet scripting. Python comes with standard Internet utility modules that allow Python programs to communicate over sockets, extract form information sent to a server-side CGI script, parse HTML, transfer files by FTP, process XML files, and much more. There are also a number of peripheral tools for doing Internet programming in Python. For instance, the HTMLgen and Pythondoc systems generate HTML files from Python class-based descriptions, and the JPython system mentioned above provides for seamless Python/Java integration. Database programming. Python's standard Pickle module provides a simple object persistence system. It allows programs to easily save and restore entire Python objects to files. For more traditional database demands, there are Python interfaces to Sybase, Oracle, Informix, ODBC, and more. There is even a portable SQL database API for Python that runs the same on a variety of underlying database systems, and a system named Gadfly that implements an SQL database for Python programs. Image processing, AI, distributed objects, etc. Python is commonly applied in more domains than can be mentioned here. But in general, many are just instances of Python's component integration role in action. By adding Python as a front-end to libraries of components written in a compiled language such as C, Python becomes useful for scripting in a variety of domains. For instance, image processing for Python is implemented as a set of library components implemented in a compiled language such as C, along with a Python front-end layer on top used to configure and launch the compiled components.